Good morning, dear children. Let us continue with chapter number 10 of physics, light, reflection and refraction. Here in this video, we will learn how images are formed by concave lens. There are two cases. Case 1, when the object is at infinity. Case 2, when the object is between infinity and optical center O of concave lens. So let us start. Case 1, when the object is at infinity. This is the object which is at infinity, very far away from concave lens, and these are light rays parallel to principal axis of concave lens. And as you know, this lens is a diverging lens, therefore light diverges. And if we produce these refracted rays in the backward direction, then they will meet at a point. That point is F1. It is principal focus. Therefore, the image is formed at F1. And as the refracted rays are not meeting actually, they appear to come from the point F1. They appear to join at point F1. Therefore, the image formed will be virtual and it will be erect. And of course, it is very small, just like a dot. You can see the size of arrow. It is big, whereas the image is of small size. Case 2, when the object is between infinity and the optical center O. What does it mean? It means that the object is lying anywhere on the principal axis. Here in this case, say this is the object, first ray of light parallel to principal axis, and then it diverges. Second ray of light passing through optical center. Now these two rays, after refraction, they will not meet at all. So what we will do, we will produce the first ray which is diverging in the backward direction, and as a result, these two rays meet at a point, and at that point, the image is formed. Here you can see the image, and this image is again virtual and erect, and it is of small size. So it is the concave lens in which the virtual and erect image is formed in both the cases, and the size is smaller. Now let us talk about sign convention for spherical lenses. The sign convention for spherical lenses, it is same as in case of spherical mirrors, except that the distances in this case are measured from the optical center O. Now what does it mean? Here we have the lens, this is optical center O. All the distances towards the left side, they are negative, and the distances towards the right side are positive. As you can see, object is placed on the left side. Therefore, U will be negative. U is object distance. And here in this case, the image is formed on the right side. So, V will be positive here. What is V here? V is image distance. But if we have virtual image, then you know virtual image is formed on the left side of the lens, whether it is concave lens or it is convex lens. So virtual image is always formed on the left side of the lens. So in case of virtual image, V is negative. Next, the height which is measured in the upward direction, that is positive. So we have height of object positive, and the height which is measured in the downward direction, it is negative. Therefore, height of a real image is negative. Height of object is always positive because object will be kept above the principal axis. Whereas in case of real image, the height will be negative, and in case of virtual image, the height will be positive. Now let us talk about lens formula for spherical lenses. The lens formula for spherical lenses is the relationship between the object distance u, image distance v, and focal length f. So here we have lens formula 1 upon v minus 1 upon u is equal to 1 upon f. Now what do you mean by magnification produced by spherical lenses? Magnification for spherical lens is the ratio of the height of the image to the height of the object. It tells us the image will be bigger than the object or it will be smaller than the object. Like if magnification is say 3, it means image will be 3 times bigger than the object. But if magnification is 1 by 3, it means image will be 1/3 of the size of the object. So this is how we can understand about magnification. So magnification is height of image by height of object. It is HI upon HO. In your NCERT book, the symbols are different. There they have used H dash and H. H dash for height of image and H for height of object. You can use that also. Magnification is also related to object distance and image distance. And what is that relation? M is HI upon HO. It is also equal to V upon U. So here you are to remember that if we have negative sign in the lens formula, then in magnification with V by U, we will have opposite sign. That sign is plus. So once again I am telling 1 upon V minus 1 upon U. Here we have negative sign. And with magnification, when magnification is related to V and U, then with V divided by U, we will put the opposite sign, that is plus sign. Next is power of lens. The power of lens is the reciprocal of its focal length in meters. If focal length is given in meters, then power will be 1 upon f. But if focal length is given in centimeters, then formula for power will be 100 upon f. Or we can talk about focal length also. Focal length will be reciprocal of power. When focal length is taken in meters, then SI unit of power will be diopter. The symbol is D here. Now let us define 1 diopter. 1 diopter is the power of a lens whose focal length is 1 meter. So as you can see, if I put 1 here, so P also becomes 1 diopter. The power of a convex lens is positive, whereas power of concave lens is negative. How is it possible? We know that focal length of convex lens is always positive. Therefore, power will also be positive. And focal length of concave lens is negative. Therefore, power of concave lens is also negative.